Hello students, today we will discuss about wave-particle duality of light. We have seen that light was initially considered as a particle. The concept was given by Sir Isaac Newton in his corpuscular theory, where he explained light as consisting of particles or corpuscles which travels in straight line. Based on corpuscular theory, Sir Isaac Newton could explain some of the phenomena involved with light, that is reflection, that is bouncing from one medium, and refraction, that is bending of light when it travels from one medium to another. But he could not explain other phenomena of light like interference, which is superposition or adding up of amplitude of light, and diffraction, that is bending around the objects using the corpuscular concept or particle concept. So in order to explain interference and diffraction, wave theory was established by Christian Huygens, and it was applied by Thomas Young in explaining interference as well as diffraction. And it could also explain reflection, refraction based on the wave nature of light. So everyone thought that the light will be considered as a wave, and that is how Maxwell has proposed the light as an electromagnetic wave. But later on, it could not explain some of the phenomena which has come up in the light, that is black body spectrum and photoelectric effect could not be explained using the wave concept. And it was Max Planck and then Albert Einstein who proposed that light is consisting of packets of energy, and those packets are called photons. So based on the concept of photon or particle, he could explain the photoelectric effect. So there was a dilemma whether to consider light as a particle nature or with a wave nature, and that led to the scientists to believe a wave-particle duality for the light. That is, light can sometimes exist as a wave nature, and at other times it can exist with a particle nature. So this wave-particle duality was evident with the concept of photon itself. That is, if you consider energy of a photon, Einstein has proposed that, or Max Planck has proposed that energy of a photon will be given by Planck's constant into frequency. But you know, a particle which is moving at the speed of light, which is called relativistic particle, will have an energy given by E square total energy, square of total energy, that is E square equals C square P square plus M0 square C raised to 4, where P is the momentum of that particle and M0 is the rest mass of that particle. And you know, the photon is the light itself, and hence it will also be having this kind of relativistic energy. But for a photon, the rest mass is 0. So this term will goes off, and finally what you have is only the first term alone. So E square equals C square P square, and taking the square root, what you get will be E equal to C into P. Okay, so you can substitute for E from this equation. It is just C, which is velocity of light, into P, momentum of the photon, is equal to h into nu. From this, we can rearrange the equation where the momentum of the particle P is equal to h into nu divided by c, velocity of light. And if you consider a wave motion, the velocity of a wave is given by frequency into the wavelength of the wave. And rearranging, what you require is nu by c. Rearranging this equation in that way, you'll get nu by c is equal to nu by c. So lambda is taken to this side, so it becomes 1 by lambda. So instead of nu by c, we can substitute 1 by lambda. So the equation now become the momentum of particle is equal to h Planck's constant divided by lambda, wavelength of the light. And you are just taking a 2 pi in the denominator and a 2 pi in the numerator. Then you can express the momentum of particle as equal to h cross into k, where p is the momentum of particle and k is the wave vector. So it is evident from this particular equation there is a particle behavior is related with the wave nature, and this is a wonderful expression for a word particle duality of light wave. So again, the scientist has a dilemma when to choose a wave nature for the light and when to choose a particle nature for the light. So they came up with a solution that a particle nature will be considered whenever the energy of interaction is comparable with the energy of the photon. That is, whenever the energy is comparable with the h into nu, then you'll consider the light will be interacting as a particle. And whenever the size of the object interacting with the light is comparable with the wavelength of light, then you can consider a wave aspect for the light. Okay, so that explains wave particle duality of light. Thank you.